Welcome back to Summarize Science. Today, we are looking at a fascinating development in how AI understands our world from above. Aerial imagery from drones and satellites is vital for everything from navigation to disaster response. However, training AI to understand these photos is incredibly difficult because human labeling is often imprecise. To solve this, researchers have created SyMTRS, a massive synthetic dataset designed to be a gold standard for aerial AI. Think of it as an ultra-realistic virtual world where every single pixel is perfectly accounted for. One of the biggest hurdles in remote sensing is that we lack accurate depth information and perfect nighttime matches for daytime photos. If you want an AI to estimate distance or see in the dark, you need to show it exactly what the truth looks like. The researchers used the Matrix City project, which was built in the powerful Unreal Engine 5, to create a photorealistic urban environment. By using a game engine, they could automate drone-like camera paths at various altitudes to capture every possible detail. This allowed them to generate over 1.5 million frames of high-resolution cityscapes. SyMTRS provides three main tools for AI training: super resolution, day-to-night translation, and depth mapping. Super resolution is essentially the enhance button you see in movies, turning blurry low-resolution images into sharp high-resolution ones. Because the data is synthetic, the researchers can provide a perfectly clear version alongside a blurry version for the AI to practice on. They also created matched pairs of the exact same city scenes captured at both day and night. This helps AI learn to recognize a building's shape even when the lighting changes completely from sunlight to artificial street lamps. When testing various AI models, they found that simpler models often performed surprisingly well if the training data was high quality. These charts show how different AI brains compared when they were tasked with sharpening blurry aerial images. Interestingly, sharpening images gets exponentially harder as the starting quality gets lower, which this dataset proves quite clearly. We can see the visual results here, where certain models managed to keep roof boundaries sharp while others struggled. The researchers also tested various systems to see if they could successfully turn a nighttime image back into a clear daytime view. While the AI is good at keeping the basic city layout, it still struggles with the fine details hidden in deep shadows. This shows that, even with perfect training data, some tasks remain a major challenge for modern technology. To recap, SyMTRS is a huge step forward because it provides a unified way to test multiple AI skills at once. It offers pixel-perfect depth, consistent lighting changes, and multi-scale resolution data for better testing. In the future, this work could lead to much smarter drones that can navigate cities autonomously and more safely. It also means satellite images could be digitally enhanced to show details we previously could not see from space. By bridging the gap between virtual simulations and the real world, the researchers are paving the way for more robust aerial AI. Thanks for watching Summarize Science, and stay curious about the technology shaping our future.